Hi, my name is Lisa Pasquale. So I'm the technical lead at Retrofit Works. I'm an accredited retrofit coordinator. I was one of the instructors and tutors on the retrofit coordinator course with Retrofit Academy. So a bit of background, I'm trained as an architect, but chartered as a building services engineer. So I bridge the two in terms of building performance, is making sure that the fabric and the systems are properly coordinated and dealing with the hygroscopic risk and the overall safety and sustainability of the building. So I developed the risk triage process that is in PAS2035, the matrix that you might have seen in one of the back appendices as part of a previous bit of work with Greater London Authority about probably 8 years ago now. So I'm going to be explaining a bit about the PAS25 compliance process and how it differs from what you guys have probably encountered before. So this is the introduction to Social Housing Demonstrator Fund and SHRA. I believe Sarah covered most of this kind of in her presentation. But at the moment, the Social Housing Decarbonisation Demonstrator Fund is active. So I'm one of the technical advisors to BAYS on that batch of funding, which went out, I believe the MOUs went out in kind of December, January last year. So I look after all the projects in the north of the country because I'm based in Glasgow, and my colleague looks after the projects in the south of the country. And so this is part of the sort of next phase of the fund that should be coming out relatively soon. So a bit about the PAS2035 process. So there are kind of 6 key steps to the process that are quite important that you sort of understand. And a really unique thing about PAS2035 versus any other publicly available standard is that PAS2035 is ultimately about regulating the process by which you deliver retrofits. So it's really about regulating the project management process. It's not remotely actually a technical standard. So it's not saying you have to have X amount of insulation, you have to have X amount of this, you have to have values for X, Y, and Z. It's really about regulating who signs off what, who designs what, who checks what, who does what in the correct process, such that there shouldn't be mistakes being made. So people shouldn't be inappropriately substituting things. Builders shouldn't be able to put in the wrong insulation. You shouldn't be able to get to a stage of a project without ventilation having been accounted for. Effectively, what it's doing is trying to stop all the gaps that were occurring in the retrofit process during CESP and CERT that were allowing bad decisions to get quite far down the line before someone flagged them, because very often it was us technical people that were sitting way down the end of the line who kind of got engaged way too late. And by the time we showed up, we said, look, there's no budget left. There's nothing we can do to fix what you guys have kind of already done. And now we've got a project that fundamentally doesn't work. And PAS2035 is about fixing that process and fixing that project management process to make sure that we don't get that far down a project without key things being considered and resolved at the right time. So the first step is the most important. It's defining what the intended outcomes of the project are. And these can vary quite a bit. I mean, the general gist of it is usually it's about comfort, energy, and carbon. But the fact of the matter is you've got people in different situations that have different priorities. So it might be in some instances that comfort is the highest priority. If you happen to save a bit of energy, brilliant. If you don't save energy, not such a big deal. Or, and this is especially the case in fuel poverty, a lot of times they're underspending on fuel so severely. The only thing you're really doing is bringing them up to a comfortable level of habitation. You're not actually cutting their bills because their bills are so ridiculously undercut to begin with. And so being quite clear what the intended outcomes of the project are, because there's no point in pursuing certain retrofit strategies if the intended outcome, if they're not going to serve the intended outcomes. So those need to be clearly defined at the very beginning of the project. They need to be written out and they need to be agreed with the householder. There needs to be this is Retrofit Academy slide. I slightly disagree with the sequence. There needs to be a whole dwelling assessment. Usually that would come second, where basically we look at the house and decide what's feasible, what can we do to it, what can't we do to it, how do we need to go about doing the works, what things can be retained, what things need to be stripped out and changed over. And this looks at a holistic view of the property. So for example, if we're switching over to heat pumps, ideally, we do want to be looking at what are the pipe size, what are the pipe runs that are going out to the radiators? Can those radiators be retained? If we put more insulation in, will that adequately mean that the radiators are adequately sized to switch from a high temperature boiler to a low temperature heat pump? We need to look at that in quite a lot of detail to be able to scope out a retrofit and make sure that it's suitable. So that whole dwelling assessment looks at the entire dwelling, the fabric, the services, everything else. But most importantly, it looks at the ventilation, which is something that has always fundamentally been missed out in retrofit. So we need to make sure that the ventilation is accounted for, that it's been fully designed. We need to be looking at the whole dwelling assessment in terms of ventilation, in terms of fabric, in terms of services. From that, we get a set of likely measures that should be suitable for that property, and we're going to do a bit of an option evaluation, option appraisal, to then decide on what the given package of measures will be for that house. That then goes through a risk assessment process, and basically what the risk assessment process is there to do is identify the fundamental conflicts between different measures. So where there are potential issues with regard to thermal bridges, with regard to needing coordinating specifications, needing coordinating details. And that's to make sure that we understand the level of risk of the project, we understand where key details and specifications need to be produced, and then the PAS defines what qualifications of retrofit designer needs to then produce those details and those specifications. And it clearly gives a person spec that they need to have XYZ qualifications if you're in a Path A project. They need to have XYZ plus ABC qualifications if you're in a Path B project, and then higher still qualifications if you're in a Path C. And that risk assessment helps make sure that you have a team that is appropriately matched in terms of their skill set to the complexity of the project. From that, you then go into design and coordination. So then those retrofit designers are sitting down and sussing out all the details. And that should be basically a house by house, detailed, dimensionally accurate, materially accurate plan for how exactly that design is going to be executed. Then we go to installation, not hugely different from what it was before. So the PAS 2030 installers go in, do their works. The main thing is us retrofit coordinators then check and make sure that they are in fact doing works to the correct standard. And then a key thing that is, again, quite new, which has never really been part of the process properly before, is monitoring and evaluation. And ultimately, that's about going back to step one, the intended outcomes, and making sure that they were actually achieved. So if you said at the beginning, we're going to make this house more comfortable because the occupant's freezing and they're in fuel poverty and they're struggling to pay bills and heat the house, the questions you're going to ask at the end of the project are you more comfortable? Are you able to heat your house more? Are you able to heat more rooms in your house? You're going to want to actually assess, did we achieve the outcome of giving them a more comfortable house? Because if we go back after the fact and we find out it's full of mold, it's still drafty, it's still cold, we've gone through this whole process, we have not achieved the intended outcomes, the retrofit hasn't worked, and then we need to go back and we need to rectify it. So that is the PAS 2035 process. So the basic statutory requirements, which you need to really be quite aware of, is in order to comply with PAS 2035, the works must be carried out to PAS 2030-2019. So 2030-2019 defines how each individual measure needs to be designed or installed. PAS 2035 just defines the overall project management process. So these two are designed to work in coordination with one another. The retrofit coordinators installers need to be registered with a Trustmark accredited scheme. So this gives a kind of a bit of a dispute resolution process, a complaints process, a structure to how they need to handle complaints, how they need to handle any kind of non-performance or inability to meet intended outcomes. and it gives some structure around basically protecting the householder. And then we need to be issuing certificates of compliance with Trustmark as the retrofit coordinator, along with a number of key project documents. So the PAS2030 installer will have their own set of documents that they are going to need to put on file with Trustmark. So that's going to be their assessments, their kind of what exactly they installed, the process they went through, key pictures of what they did. So they have their own process they need to lodge with Trustmark. As a retrofit coordinator under PAS2035, we have a separate one we need to lodge with Trustmark. So they're not the same. So the key documents for retrofit coordinators that we need to lodge are the retrofit objectives, the intended outcomes, what was to be targeted, the option evaluation, the ventilation assessment. So this is its own specific document to make sure that the ventilation has been addressed, it has been assessed, and it has been remediated if it was required. The retrofit plan, what exactly was going to be done, how, with what materials, products, and systems. So that's the overall kind of strategy for the retrofit. The risk assessment to make sure what risk path the project is going down, and to identify what key details and specifications need to be coordinated. The medium-term retrofit plan, which then identifies works that are to be done in the future to upgrade the entire home. So if you're only doing a partial retrofit now, what things might they look to do in 5 to 10 years? A certificate of compliance that's confirmation the works were done by the standard, and a monitoring and evaluation report. And that should be verification that the retrofit did in fact meet the intended outcomes. So what's fundamentally new compared to how we used to deliver retrofits is basically everything in red. That is stuff that we have never really done before as part of a standard retrofit project. We never did ventilation assessments. We never clearly defined retrofit objectives for individual households. Usually they were quite vaguely defined and they were very difficult to go back and measure after the fact. These need to be measurable outcomes. So if you remember your kind of project management language, SMART, S-M-A-R-T, measurable, a measurable outcome that you can verify after the fact. The option evaluation, the risk assessment. So this is an entirely new process that was developed as part of PAS, under PAS2035 and the previous GLA schemes. And the medium-term retrofit plan is giving the householder a plan going forward if they can't do an entire retrofit in one go. And like I said, verifying outcomes. Previously, the outcomes were so poorly defined, it was really difficult to go back and then say, well, did we achieve that? Because they were usually quite vague. So I've given an example of new wall installation requirements for PAS 2030 and 2035 and 2030-2019. So this is mostly for EWI. And this is things just from under the new decarbonisation fund demonstrator that we've noticed a few housing associations, local authorities have been a bit caught out because they didn't clock some of the changes in 2030-2019 for EWI. So one of the key things that needs to be dealt with is PAS 2030-2019 for EWI requires the resolution of all thermal bridges to avoid condensation and moisture risk. We have to be able to demonstrate that we have adequately resolved the thermal bridges. We need to make sure that the temperature factor of the physical surface, so we need to demonstrate that the temperature factors on the surfaces that might be a potential thermal bridge are below a certain number. There's an actual number value we need to demonstrate. And this is something that needs to be calculated. It's not something that we can just sketch out on the back of a napkin and hand it to a contractor and say, yeah, that should more or less do it. So we do need to be doing thermal bridge calculations as part of this. So thermal bridge calculations are quite important. So you need to take into account the fact that those sometimes take time to do. And they also need to be specific to the construction that you're working on. So sometimes system designers, system providers will have standard details and they will have standard psi value calculations and standard temperature factors. But if your underlying construction on your building is not the same as that standard detail, those numbers don't mean a thing. So you have to make sure that that actually does line up. So we need to make sure that we're addressing window reveals, party wall returns, eaves and gable ends, and including the appropriate ventilation. So the plinth insulation is one of the biggest ones that has caught people out. So there are different ways of resolving the thermal bridge at the ground level of a property, and it's effectively where the EWI tends to stop at the DPC, DPM on the outside. And depending on where exactly the floor and the ground is in relation to that, sometimes you end up with a big stonking thermal bridge right at the bottom of the wall. And the plinth insulation is required to resolve that, such that we make sure that we don't have a thermal bridge all the way around the perimeter of the bottom of the property. So this is quite an important thing to consider, because if you are in a situation where you're going to have to excavate around the outside of a property to be able to insulate down into the ground, that is a lot of work. It's a lot of groundworks. It's quite expensive. It's quite time consuming, and it's going to involve things like moving sewers away, moving drainage away, moving potentially gas lines away. So you will have other things that need to be dealt with below the DPM, DPC, and those can be a quite significant cost if you haven't kind of planned that in advance. So here's an example, plinth foundation insulation that's going on XPS below the DPC. That's going about 400 mil down the outside of the wall, and as you can see, this involves quite a lot of excavation. It's going to involve shifting drainage away from the foundation and moving it out so that you can slip the insulation behind it. This is a level of work that just the industry has not really dealt with before, and it's one that we are not used to costing into projects. So please do be aware of that, because that has caught a number of projects out on the demonstrator project. Party wall junctions, so where we've got one house being insulated with EWI but the adjacent house is not, we do have to resolve the thermal bridge here using an internal wall insulation solution of some description, and that's basically because without doing so you end up with a thermal bridge right through that party wall junction, and under PAS2035 we cannot do that. We cannot do things like this. So this is, I believe, Fishwick. So this is the Preston project. This was a whole host of failures, but fundamentally the kind of biggest clangers were poorly detailed and disconnected rainwater goods that allowed water to just dump all over the place, and very poor detailing that allowed water to then get back behind the insulation. So a lot of things like this, stepped flashing, we cannot be doing that anymore. The insulation needs to be brought all the way up. The gutters moved out to the outside. So this is all disallowed now. So a more kind of substantial solution is extending guttering out the side and out the bottom, and effectively allowing that to then cap the EWI, so that you've got a properly fully flashed rainwater solution that's acting both as a terminator for the EWI and also doing all the rainwater control. And as you can see, the size of that means that you're highly unlikely to get water spillage over. Skeelings, these were often very often left uninsulated, because weirdly you do EWI to here, you do loft insulation to here, and you end up with this little teeny strip that is unfunded work in between the two, and that very often just got left uninsulated, which is usually that little strip of roof right there. So these have to be resolved under PAS2035. In this case, a small bit of IWI fully adhered would have probably sorted it out quite easily. But we need to be very careful about what system is chosen, whether or not it's compatible with the other insulation, whether or not we have adequately resolved the bridge between the different installations. There's a lot of coordination that needs to go on to make sure that that's done properly. Window and door thermal bridges. Oops, wrong sequence. So we have two options. Option one is to move the window into the plane of the insulation. So under PAS2035, this should always be the first choice. And the reason for that is that one, it fully automatically resolves the thermal bridge. It requires no change in the insulation material strategy and ensures the window detail is fully covered under the EWI warranty and guarantee. But it might require the residents move out for a couple of days. So ideally, this is what we should be doing. Obviously, that requires either changing out windows or shifting them out. The other option is insulating the reveals. If you do this, it then becomes a lot more complex because you have to have a lot of design evidence that supports that you have adequately designed those reveals to be correctly insulated, that they are the correct temperature. And then effectively, once you've put the insulation on the inside of the reveals, all of that IWI is outside the EWI's warranty. So if that IWI fails, you then have no financial protection to go back and say, actually, you know, now we've got mold on the inside of these reveals, it's not really working. You've got no recourse effectively to financially protect that work. And that's why we suggest moving it into the plane of the insulation, is then it's fully covered under the EWI warranty. And it's done in this manner, effectively shift the window out, put it on a timber sill, insulate straight around it, and that sorts out the thermal bridge. Doing it internally requires quite a lot more work, again, outside the main scope of the EWI. So I've kind of covered a lot of technical things in this, but mainly I focused on this because working on the demonstrator project, these are the things that have caught projects out for being unaware that they were required to do that. And they've kind of come back and said, oh, we've not costed for that, we've not costed for this. So that's why I kind of wanted to highlight some specific issues around the compliance requirements in technical terms.